Okay, so we are up to hyperbolas, which I believe, I better fix this, is 10, 1, 3. But having said that, you can see behind the paper that there are instructions about hyperbolas, but let me kind of break this down for you. There's two types. Number one, there's a hyperbola, which looks like that, but that's only half of it. The other half is like that. So that means it's the two parabolas are facing up and down. Or the second kind of hyperbola is going to face to the left and to the right. Now, for memory purposes, I turn these hyperbolas into Pac-Man. I don't know if you've ever played Pac-Man before, but notice these Pac-Man would be gobbling up the dots on the y-axis. This one would be going down, this one would be going up. If these were Pac-Man, they'd be gobbling up the dots on the x-axis, that one in the negative direction. That Pac-Man is going in the positive direction. Now, that is significant because you were just taught about ellipses, and the big point with ellipses is A is bigger than B. So we had things like this: x squared over a squared plus y squared over b squared equals 1. And because the a is underneath the x, we know that ellipse would be longer along the x. If we switch this and went x squared over b squared plus y squared over a squared equals 1, because the a squared is underneath the y squared, we know it would be longer along the y. Now there's little clues like that for hyperbolas. Hyperbolas, I'll just start with this one, and that is going to be x squared over a squared minus, notice, ellipses are plus, hyperbolas are minus, y squared over b squared equals 1. Notice ellipses are equal to 1, so are hyperbolas. But now let's take a look at this. A in an ellipse is bigger than b because it establishes the major axis. So there's my major axis, which is my x-axis. A is underneath my y, so that means my y-axis is my major axis. This is different. In hyperbolas, A can be bigger than B, B can be bigger than A could even equal B. You don't see this very often, so just understand that they can be switched around like that. What's significant is, I want you to notice in this one, my A comes first, or my A is from my positive stuff. Notice this is my negative stuff. And notice, because it's positive and it's underneath my x, my Pac-Man are eating the dots on the x-axis. Now what would this one look like? Well, this one would look like y squared over a squared minus x squared over b squared equals 1. So notice my a is underneath, well, it's part of my positive stuff. And that means because it's under the y, my Pac-Men are going to eat up and down. So, with that in mind, and there's a lot more, but there's a formula. Remember, ellipses was a squared minus b squared equals c squared. That helped us find the foci. And notice, interestingly, the plus is part of the ellipse, but the minus is part of the formula. For a hyperbola, minus is part of the equation, plus is part of the Pythagorean relationship. Now that is exactly the Pythagorean theorem, but this has to do with dimensions, which I'm about to share with you. So let's take a look at this one right here. So this says, sketch the graph of the hyperbola by hand. Well, the first thing we got to do is find the center. So we look at this and we say, aha, that's 1 to the right. This is 3 to the left. So we go 1 to the right. Did I say left? Anyways, it's early in the morning, so here we go. 1 to the right, 3 down. So 1 to the right, 1, 2, 3 down. So there's our new center. Now what I like to do is build a brand new XY axis, understanding that my new origin is 1, -3. So with that being said, we need to now build what I call the box. Now I haven't mentioned the box yet, but here it comes. We're going to actually build what's called our asymptotes. And you're going to see this in a minute. Where does the box come from? Well, here we go. This right here is a squared. Notice my a squared comes first regardless. Or it's part of my positive stuff, part of my positive stuff. So I know that this is part of my positive stuff, so a squared equals 2. Now if I take the square root of that, it's approximately 1.4, which means I need to travel along the x direction 1.4 units. So I know this is kind of tight, but there's 1.4, 1.4 in the x direction. Remember what I'm doing, I'm building my box. Now you're wondering, why are you building a box? You'll see. This is b squared, so b squared equals 4. This is easier, so we get exactly 2. But we travel up the y-axis and down the y-axis 2 units. So 1, 2, 1, 2. Now here comes the box. This is very unique to the hyperbola. Now why did we build the box? So that we can find out where our asymptotes are. The asymptotes are simply diagonals right through, whoops, that wasn't perfect, but, and then right through diagonals of the box. The next decision we have to make is it going to be Pac-Man going right and left, or are they going to be Pac-Man going up and down? Notice y squared's the positive stuff, so they gobble up the y-axis. X squared's the positive stuff, so they gobble up the x-axis. Because this is x, they're going to be they're going to be this way. Now, what's significant about all this stuff, this box? Well, because we know it's like this, we got to find out where these parabolas' vertices are. Well, those are right here and right here. And the asymptotes tell us, they're kind of like the guides. And there's the hyperbola. It kind of determines the width or the wideness of the hyperbola. And there it is. We sketched the hyperbola by hand. Now, just so you know, let me pause this a second. All right, I had to find my pretty colors because I want to point something out to you from this notes here. The transverse axis is 2a. So what the heck is that? Well, don't get confused with the ellipse. Remember, in an ellipse, and I mentioned this, a is bigger than b. That is not necessarily true for hyperbolas. A built what's called our transverse axis according to this. The transverse axis is the axis where the vertices were. Remember, A equals 1.4. That was the distance we went that way and this way. So there's the transverse axis. And this is very tight. But this little smidge is A, this little smidge is A. That's why the whole thing is double A. So with that being said, what's the conjugate axis? Now don't forget, on the transverse axis, that's where the vertices find their home. So conjugate axis would be the other one. That's right here. Remember what we said? B is 2. We went up 2, down 2. That's why it's 2b. Okay, with that in mind, now they're going to come at us with some information we need to interpret it. It says, find the equation in standard form for the hyperbola that satisfies the given condition. So, I'm going to draw it over here. It says transverse axis endpoints. That's important. Are 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 3. Now what we can gather from that is, this is negative 7, 3. Hope you can see that. This is 5, 3. So that's like this point and that point. So to find the center of the hyperbola, we got to find the middle point. Well, if this is 7 to the left and 5 to the right, that's 12. So I need to move 6 in from here or 6 in from here, regardless of how I look at it. There's the center of the hyperbola. So right now I know the center is -1, 3. I also know, because this is the transverse axis endpoints, that these are the vertices of my hyperbola. I don't know what it looks like, but that tells me my Pac-Man are going to be gobbling up my x-axis. That tells me my x's start, and here's my shift to my center. So I go x plus 1 squared over a squared minus, and then my y value is up 3, so I got to go -3 squared over b squared equals 1. Now we got to figure out what a is and then square it. We got to find out what b is and then square it. But they're going to give us some clues here. We already have a major clue right here. We already talked about it. That distance from here, the center, to the vertice is a. That's the same thing as this, which is a, which what is it? It's 6. So what do? We square it and put it right here. So what is 6 squared? 36. Now look at it. They spoon feed us the conjugate axis, which means if we were to build a box, which we don't have to because it doesn't say graph, it says find the equation. But we're trying to find this distance here. But the whole axis length is 10. So they're telling us from here to here is 10. What's half of that? 5. So now we're going to take the 5, square it, and then we will put it right there, so that would be 25. And there's the answer for example 2. Okay, so they're hitting us with everything they got. Transverse axis endpoints, -2, -2. Let's get a nice little drawing here. -2, -2. And -2, 6. So -2, now we got to go up 3, 4, 5, 6. So that's helping us a lot, because now we're going to find if this is -2, -2, and if this is -2, 6, we got to find the halfway point. Well, if this is 8, we need to go 4 down or 4 up. Regardless, we end up with the center 2, 2. Also, it's telling us that, whoops, I shouldn't have done it from the center. It's from here where the hyperbolas are going to grow. So my Pac-Man's eating my y-axis, which tells me a lot. This distance is 4, which is my A, and so here we go. So we can get started. Here's my center. I know it's Pac-Man going up and down, so I know it's going to be y. Here's my y shift, -2 squared over a squared, which we can decipher from that little drawing. So that's 16 minus x minus 2, because that's our x shift from our center, over b squared. Not sure what that is yet. Now what is this? The slope of one asymptote is 4 over 3. Like what? Well, remember the box. So the slope of an asymptote, this is referring us to the box. So if we were to graph it, we would have to build the box. It's saying one of the asymptotes has slope 4. Now where did they get that from? It's the vertical change. 4. They already kind of repeated part of what we already knew. So remember, this is rise over run. That's what slope is. So where do we run? 3 to the right. 1, 2, 3. So if we were to build a box, it would look like this. But they're not asking us to build a box. They're just telling us B is 3. That's B, half of the conjugate axis. So now we know we can just put a 9 in there, and we're done. This one, a little different. Find the center. Let's start there. Left 4, 1, 2, 3, 4. Down 6, 1, 2, 3, 4, 5, 6. There it is. So the center is -4, -6. That's what the center is. vertices. Well, first of all, because my x squared stuff is like this, I know my hyperbola is going to go like that, because my Pac-Men need to eat the x-axis. This is also telling me that a squared is 16, so a is 4, which tells me from here, remember this is my new center. I like to look at it that way. It's like my xy axis just shifted, but my new center is negative 4, 6, which is important to keep track of. But now I need to move 4 to the right and left because it's x. So that would put me right here and right here. Now, what is this? Well, that is b squared because it's second. So I take the square root and I get 5, which means I got to go 5. So if I went down 6 here, I got to go up to here, and 1, 2, 3, 4, 5 down to there. Now this is going to be a mess over here, but I'm going to go ahead and do it. Not enough space. And there's my asymptotes like that. And I know my hyperbola is going to go like this. Has to, because it starts with x. But now my vertices are right here and right here. So this is 0, negative 6. This right here, now this was negative 4, negative 6, and we went 1, 2, 3, 4 units to the left of that, so that has to be negative 8, negative 6. So there's my vertices. Now what's the foci all about? Well, I didn't share this with you, but in the drawing, the foci is, hopefully it's in the picture, and it's not. But the foci, we're going to get it from, I'm going to teach it to you backwards, a squared plus b squared equals c squared. C is the distance to the foci. The foci are going to be somewhere here and somewhere here. Now, a squared is 16, b squared is 25, so I get 41 equals c squared. So I take the square root of both sides, bada boom, bada bing, do the right thing. Now, this is the distance I need to move from the center this way to find the foci, and from the center this way to find the foci. So, this point right here is negative 4, negative 6, but if I need to move left, the square root of 41 from negative 4, and right, the square root of 41 from negative 4, my foci would be negative 4, that's my x value, plus or minus the square root of 41, comma, negative 6. And that's how you would write the answer, which would take you somewhere over here and somewhere over here. The parabolas always go around the foci, always go around the foci. All right. Now the last two, they don't say graph it, it just says rewrite it in graphing form. Well, the thing you need to get started with is looking at this and saying, hey, that needs to be a 1. So the first thing you should ask yourself is, would it be a good move to divide by 144? And the answer on this one is yes, and I'm going to show you why. 16, that turns into 1/9, so this is y squared over 9 minus x squared, and 9 divided by, or 9 goes into 144 16 times, so it's 1/16 and 1/9. And now we've got it in graphable form. Now, does it say to graph? No. It just says rewrite it. Well, we just did. So now we're all creatures of habit. We're like, hey, they got to equal 1. So I'm going to add 121 over to both sides. I'm going to rewrite this. 4y squared minus 8y minus 5x squared minus 30x equals 121. Again, we're creatures of habit. We divided by 144 on this one, and everything just worked out. So creatures of habits, like, oh, okay, I'm just going to divide by whatever this is. Well, look at it. There's no way all of these numbers are going to be nice and neat like this one was. So there must be something else we need to do. And here it comes. So for this one, what we're going to do is we're going to complete the square. Yep, here it comes again. But we got to factor out a 4 from this first. We got to factor out, what I'm going to factor out is a negative 5. because I know this is a hyperbola and I know I need a negative in there. And then I end with x squared plus 6x plus space plus, whoops, equals 121 plus space plus space. Half of negative 2 is negative 1. Squared is 1, but 4 times 1 is 4, so I got to add 4 to that side too. Half of 6 is 3. 3 squared is 9. 9 times negative 5 is negative 45. Now watch what happens. So this is a perfect square trinomial. So that's 4 times y minus 1 squared minus 5 times x plus 3 squared is where we're going to get our centers from. And this is 125 minus 45, which is 80. And now that I've got things cleaned up, and these are handmade, I'm going to divide by 80, because I can see this reduces quite well. Y minus 1 squared over 20 minus x plus 3 squared over 16 equals 1. And then we would be able to graph it. So, have at it. Homework's kind of intense, but good luck.